Hey guys, Louise here. You want to know about Avogadro's law? Well, lucky for you, I'm gonna teach it right now. Avogadro's law is an experimental gas law relating to the volume, the amount of substance, gas present. The law is a specific case of the ideal law given. Modern law statement is Avogadro's law states that equal volumes of all gases at the same temperature and pressure have the same number of molecules. For a given mass, an ideal gas, the volume and amount of moles of the gas are directly proportional if temperature and pressure are constant.
The law is named after Amadeo Avogadro, who in 1811 hypothesized that two given samples of an ideal gas of the same volume and at the same temperature and pressure contains the same number of molecules. As an example, equal volumes of molecular hydrogen and nitrogen contain the same number of molecules when they are the same temperatures and pressure and observe ideal gas behavior. In practice, real gases show small deviation from the ideal behavior and the law holds only approximately but is still a useful approximation for science.
The law can be written as B or volume is inversely proportional to N equals, or B is divided by N is equals to K, wherein B is the volume of the gas, N is the amount of substance of the gas, measured in moles, and K is a constant for given temperature and pressure. For comparing the same substance under two different sets of conditions, the law can be usefully expressed as P sub 1 over P sub 1 is equals to P sub 2 over P sub 2. The equation shows that as the number of moles of gas increases, the volume of the gas also increases. Similarly, the number of moles of gas is decreased, then the volume also decreases. Thus, the number of molecules or atoms in a specific volume of ideal gas is independent of their size or the molar mass of the gas.
Hey guys, want to know some more real-life applications based on Avogadro's law? Well, it's your day today because my friends are going to give some examples. So, let me be the one to do the first. As you blow up a basketball, you are forcing more gas molecules into it. The more molecules, the greater the volume. The basketball then explodes. Remember that, kids?
Another example is that a flat tire takes up less space than an inflated tire because it contains less air.
Another example, lungs expand as they fill with air. Exhaling decreases the volume of the lungs.
For better understanding for Avogadro's law, here are some sample problems for you to comprehend. A 6.0 liter sample at a constant pressure and temperature contains 0.5 mole of gas. If an additional 0.25 mole of gas at the same pressure and temperature are added, what is the final total volume of the gas? For the first step of the solution, we express Avogadro's law by its formula, which is initial volume over initial number of moles is equal to final volume over final number of moles. For this example, initial volume is equal to 6.0 liters, initial number of moles is equal to 0.5 moles, and for the final number of moles, we have 0.25 moles. For the second step of the solution, since we have initial volume and initial number of moles, and also final number of moles, we have to calculate for the final volume. If we derive the formula for Avogadro's law, we would come up with the formula final volume is equal to final number of mole times initial volume all over initial number of moles. For the third and final step of the solution, we substitute the given information of the problem to our formula. final volume is equal to 6.0 liters times 0.75 moles all over 0.5 moles. Cancel the same unit, which is moles, and that will be equal to 9 liters. So for the final answer, we express the answer in one significant figure, which is already done.
Now, we'll be moving on to our next example, which is this problem. A flexible container at an initial volume of 5.120 liter contains 8.500 mole of gas. More gas is then added to the container until it reaches a final volume of 18.10 liters. Assuming the pressure and temperature of the gas remain constant, calculate the number of moles of gas added to the container. For the solution, the formula that we're going to use is V sub 1 over N sub 1 is equal to V sub 2 over N sub 2. Using the Avogadro's law for the substitution, the values that we're going to get is 5.120 liter over 8.500 mole is equal to 18.10 liter over x. Now we have to solve for x, and the value of x would be 30.05 mole, which is not the moles added but the total mole count. So we still have to subtract it to 8.500, which would give us the answer of 21.55 mole following the four significant figures. Notice the specification in the problem to determine moles of gas added. The Avogadro law calculation gives you the total moles required for that volume, not the moles of gas added. That's why the subtraction is there. Concluding, there are 21.55 mole of gas added to the container.
Here's one last problem. A cylinder with a movable piston contains 2.00 grams of helium at room temperature. More helium was added to the cylinder and the volume was adjusted so that the gas pressure remained the same. How many grams of helium were added to the cylinder if the volume was changed from 2.00 liters to 2.70 liters and the temperature was held constant? Now, to solve this problem, you have to first convert grams of helium to moles. So, 2.00 grams over 4.00 gram per mole, and 4.00 gram per mole is actually the atomic mass of helium. So, that will result to 0.500 mole. The value that we got, we will substitute that to the second step, which is the Avogadro's law equation. And that V sub 1 over N sub 1 equal V sub 2 over N sub 2. We're now going to use the Avogadro's law. And substituting, we have 2.00 liters over 0.500 mole equal to 2.70 liters over x. Equating it, we will get 0.675 mole. And now that we got the value, we are now going to the last step, which is computing grams of helium added. So we have 0.675 mole, and that will be subtracted to 0.500 mole, and that will result to 0.175 mole. The answer will be multiplied to 4.00 gram per mole, which is the atomic mass of helium, and the answer will be 0.7 grams of helium. To conclude, 0.7 grams of helium was added to the cylinder when the volume was changed from 2.00 liters to 2.70 liters.